A few years ago, I was boarding a flight in New York to go to Buenos Aires. And as I sat down in my flight, I found myself next to a young woman, and we started chatting. And she told me that she had just graduated from the University of Chicago, and she was working for a cloud-based education company. Now, I had just founded my own cloud-based education company, Learning Catalytics, so I thought I better find out what she does. And it turns out that her company was making flashcards, you know, these cards that have questions on one side and answers on the other, for smartphones. I almost rolled my eyes. You know I don't place much value on memorization, so I managed to stay polite. And I did not roll my eyes. But earlier that week, I had attended a talk by a psychologist by the name of Ruddy Roedinger. He is at Washington University in St. Louis, and he studies memory. And he wrote a number of articles about memory and studying with flashcards. And he showed that if you study with flashcards, you remember quite well for a few days, 2-3 days. But if you study students a week after they studied with flashcards, you find that they only retain 35%. I thought she should know that. So I grabbed my iPad out of my briefcase, and I looked up the article, I think it was in Science magazine, and I gave her my iPad with the graph that showed the decay of memory. She looked at it for no more than 10 seconds. And then she gave me my iPad back. And she looked me right in the eyes. And she said, "But we only guarantee that they will pass the test." I went, wow. I never thought about it that way. And it brought back all kinds of memories. My eldest daughter, Natalie, was biology undergraduate at Harvard. So in the weekends, she'd drive home with me, and then on Monday morning, we'd drive back to campus together. And I remembered one Monday morning where I was sitting in the driver's seat, driving, and she was sitting in the passenger seat to my right. I look over my shoulder. Flashcards. She's sitting there with flashcards. "Natalie, what are you doing with flashcards?" I mean, we had often talked about approaches to studying, as you might imagine, with a father who is interested in teaching. And she looked at me and she said, "I have to learn all these amino acids." I said, "I have an app for that." Seriously, I mean, I do some work in biophotonics, and occasionally I need to know the amino acids. And since I'm not a biologist, I don't remember them all, but I just look them up, and then I forget again, and look them up again. What's wrong with that, right? She looks at me, and she said, "Dad, I'm not allowed to use the iPhone during the exam." Which made me realize that all of this time, I had been thinking just about the input end, the approach to teaching. And I'd, you know, basically shown this picture, just as I did half an hour ago, around the world with the statement that lectures focus on the transfer of information, but that, as you heard, education is much more, only to realize that the assessment too is often simply the regurgitation back of information from students. Or maybe if it's not regurgitation of information, it's the application of memorized procedures. And consequently, instead of developing 21st century skills, our assessment is mainly focused on ranking and classifying students. And I'm going to argue that we do not do a very good job at doing that. There's very little correlation between the grades we give and people's future success. By the way, in the break, I got a lot of good questions. There was one really important question that I got. If you do what you do in class, teaching by questioning, how do you cover everything? I told the people, they're sitting there actually, to wait, because I want everybody to hear the answer to that question. I realize now I've just launched into my second talk without answering the question. I'm going to postpone it because I don't want to interrupt my flow of thought. Remind me of that question at the end so that we can talk about that. So here's what I'm going to do. I want to talk a little bit about the purpose of assessment. Why are we assessing? And secondly, I want to tell you some problems that I have identified with our assessment practices. And lastly, because I don't want to end on a negative note, I want to suggest a few improvements to our assessment practices. So let's start with part one. I want you to get together with 3 or 4 or maybe even 5 people around you, have one person take notes, and in 2 minutes, try to write down as many purposes of assessment as you can think of. The reasons for assessing in classes at a university like this. So go ahead, get together, talk about it, write down as many as you can. There's still one person. Oh, you. Can we have your clicker?
No, I have one. Actually.
We don't need it anymore.
Oh,
I'm collecting
you're
it.
missing one. Thank you. I'm sorry.
I don't know how many I'm missing. If you still have a clicker.
Allow me. 1667.
1667.
The Thames, because there was another battle.
Yeah, it's called the Battle at Hastings, or I forgot.
I'll get that to you.
Yeah. How many of you have more than 5 reasons? Okay, got to work a little bit harder. 1 more minute.
6 okay? 6 is all right?
7 better. Solar flare. Okay, so I want to hear some of the ideas that came up. Don't rattle off your entire list. Everybody is entitled to read off one thing from their list, and then we ask somebody else. Who wants to start? Yes?
Filtering the students for higher education, graduate school.
To prepare them.
Filter them.
Oh, filter them. To filter the students. GMAT. Okay. Yes.
Increase their commitment to learning.
To basically increase their motivation to learn. To motivate the students. What else?
Planning better teaching practice.
To improve the teaching and the learning. To plan better teaching practice.
Self-monitoring of the learning.
Feedback on the learning to the students. Yeah.
To satisfy your dean.
To satisfy your dean. To check the retention over time. Unfortunately, we have only a small window, right, the semester. It would be much better if we could test it 5, 10, 15 years later. Accreditation and accountability. What else?
To make sure they're afraid of the teacher and they'll come to class.
To make sure they're afraid of the teacher, to enforce them to teach. I mean, look, all these words are so conducive to learning, aren't they? Yes. To show improvement, which require you to assess more than once. Unfortunately, I still know a lot of courses that have just one assessment at the end. To measure understanding. Understanding is sort of a vague word, but yeah, okay.
Feedback to the teacher as well.
Feedback to the teacher on the learning. In fact, here's what I wrote down. 1, to rate and rank the students. 2, to rate the professor and the course, you know, in some absolute sense and maybe in the eyes of the department. To motivate the students to keep up with the work, we heard that. To provide feedback on the learning to the students and to the instructor. To provide some form of instructional accountability. And to improve the teaching and learning. Look at all of these verbs. They're already in contradiction there. How can we do all of these things with just one type of activity? Now, in my introduction, I already mentioned that a lot of our assessment focuses on the regurgitation of memorized information, or maybe the application of procedures, often memorized procedures. I would argue that even people who say, including myself, who say they're measuring problem-solving abilities, because I think, you know, most people in engineering and sciences say that what matters most to them is students' problem-solving ability, do not really do so. And here's why. What is a real problem? If you have a real problem, you generally know what the desired outcome is. You're the CEO of a company. You have a product, you want to make the product successful. The outcome is known, successful product. The question is, how do you get there? You're managing an investment fund. Outcome is known. You want to have more money. The question is, how do you do that? You go to Tel Aviv airport because you have an interview in London. You arrive at Tel Aviv airport to take the last flight to London. The flight has been canceled. You have a problem. You know what the desired outcome is, being in London. The question is, how do you get there in time for your interview? Any problem in real life fits that pattern. A known outcome, and you have to find a pathway to that known outcome. In the sciences, take my own discipline, physics, we don't typically do that. We give the students a problem where we ask them to apply a known procedure to find an unknown answer, and we evaluate on the answer. A car is going along a road, blah, 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 it hits a tree. What is the velocity of the car just before it hits the tree? The student reads the question, thinks, what methods do I have for calculating velocities? Oh, there's equation 1, and there's equation 2, and there's equation 3. Can't use equation 1 because it has variables I don't know. Oh, I can put in all the unknowns and then just turns the crank and gets the outcome. Do you see the difference between a real problem at the top and the type of problems that we often ask them on assessment? I think that's particularly important in light of this taxonomy of thinking skills that was developed by Benjamin Bloom, who was an educational psychologist in the 1950s in the US. He made this taxonomy from lower order thinking skills at the bottom to higher order thinking skills at the top. The lowest one is remembering facts. The second one is understanding how facts relate to each other. The third one is applying, taking your understanding and apply it into a new context, one in which you have not learned. Then comes analyze, decide what knowledge you need in order to solve a particular problem. Evaluate, and all the way at the top is this elusive creativity that we all really would like to equip our students with. I would argue that in most places, educational institutions, we don't even get to level 3 applying. We get stuck before that. Even at a place like mine, Harvard. You know, in fact, I was at a university south of Boston. I won't name any names. It's a good university in Connecticut. Giving a talk about education in the physics department. And after my talk, one of the professors came to me and he said, I had something really strange happen in my class this year. He was teaching introductory physics to engineering students. And he wanted to make the physics interesting to his students, relevant. And in order to make it relevant, he put the physics in a real-world context. The real-world context that he used was baseball. I mean, there's a lot of physics in baseball, right? Trajectories of balls, collisions between balls and bats, runners running. So in class, he would use examples from baseball. On the homework, he would put baseball problems. On the midterm examination, he'd put baseball problems. At the end of the semester, he was preparing the final exam, and he realized he had run out of baseball problems. So he put some football problems on the exam. Professor, complained to students, we have never done any football problems. You're laughing about this. I don't think it's funny at all. Maybe you recognize your own students. Or maybe you recognize some of your own discomfort if you were tested on something you had not seen before. But I think that in many, many instances, that is what happens in a lot of environments. I want to actually illustrate the connection between problems and Bloom's taxonomy with a little problem that I thought of, which is a little bit like a Fermi problem. Enrico Fermi was a physicist, Nobel Prize winning physicist at the University of Chicago, and he was known to start his classes by asking questions that later became known as Fermi questions. For example, he'd walk in and he'd say, how many piano tuners are there in Chicago? A physics class, right? How many piano tuners are there in Chicago? Well, you can just guess. That would be one way, but you don't have much confidence in your guess. The other way is to think, well, there are 10 million people in Chicago, so let's say there's about 2 million families. Let's say that 1 in 10 has a piano, so there are 200,000 pianos in Chicago. One piano tuner could tune, let's say, 2 pianos in a day, so you can calculate how many piano tuners are. So you can at least get a sense of a reasonable answer, and in the process you learn something that's extremely important, thinking on your feet about things you don't know, which is what he wanted to do. Well, I'm a physicist too, and sometimes these questions just come up in my mind. One day I needed to buy a gallon of paint in Harvard Square, and there's a hardware store that sells paint right in Harvard Square. Now, there's a hotel called the Harvard Motor Lodge, or the Harvard Square Hotel, it keeps changing its name, in the center of Harvard Square that sits on stilts, elevated, 1 floor. And underneath it, there's a parking garage at street level, bounded by two streets. And typically I would come in from one street and then go in one half. There's about 20 spots. Of course, there's never a spot free because it's right in Harvard Square. Pull out in the other street and then in this half. And then, typically I would go around and around and around and around. And then you see somebody who comes and walks with keys in his or her hand. Goes to the other half, quickly out on the street, back. There's another car who gets a spot in front of you. That Saturday morning, I said to myself, you know what? I'm just going to forget about all the spots on one half. I'm going to turn off the engine, wait. And as I turned off the engine, I thought, how long will I have to wait? I thought about it. I developed a little model, and 20 seconds later, I said to myself, it's going to be 3 minutes. I looked on my watch. You know what? 3 minutes later, somebody came and freed up a spot. I felt so good. Now, imagine we turned this into a examination problem or whatever. On a Saturday afternoon, you pull into a parking lot with unmetered spaces near a shopping area. You circle around, but there are no empty spots. You decide to wait at one end of the lot where you can see and command about 20 spaces. How long do you have to wait before somebody frees up a space? I promise you, if you put this on one of your exams, your students are going to go to the dean to try to get you fired. What are the skills that you need to answer this problem? Well, you need to make assumptions. You need to develop a model and then apply that model. In terms of Bloom's taxonomy, we're all the way at the top. All the way at the top. Which of the skills listed on your left are the ones that the students hate the most? Assumptions. What if you make the wrong assumption? It never occurs that you can always revisit your assumptions. I know for a fact that in my classes, if I forget to specify something on an exam, let's say I haven't specified whether or not you can ignore friction, even if it's completely clear from the context, a hand will go up. Professor, are we assumed to ignore friction here?
But I don't answer this.
They want you to take the responsibility. So the person here doesn't answer. That's exactly what I do too. But that's not the point. That's not the point. The point is that the students want you to take the responsibility for the assumption. But think about it. The ability to make assumptions is probably one of the most important ones in life. So I'm glad you don't give the answer, because you would rob them of an opportunity of actually learning something really valuable. But that's not what happens around the world. So given that they hate the assumptions so much, we're going to take this problem and we're going to turn it into a textbook problem, step by step. So the first thing is I'm going to take away the assumption. I just add one sentence. On average, people shop for 2 hours. That's quite reasonable, right? 2 minutes is too short, 2 days is too long, 2 hours sort of right in the middle. In terms of Bloom's taxonomy, we've gone maybe down a little bit, but it's still pretty creative, right? And students would still be horrified. What does this have to do with the course? So let's take it one step further. We add the model. We add one more sentence. Assuming people leave at regularly spaced intervals. So now we have implicitly given them the model and the assumption. In terms of Bloom's taxonomy, we've dropped all the way down to applying. And still, students would be horrified. Professor, we've never done any parking lot problems before. So let's now take this problem and turn it into a standard textbook problem. On a Saturday afternoon, you pull into a parking lot with unmetered spaces near a shopping area where people are known to shop, on average, for 2 hours. You circle around, but there are no empty spots. You decide to wait at one end of the lot where you can see and command about 20 spaces. How long do you have to wait before somebody frees up a space? And you go, wait a minute, isn't that the problem that we started with? Yes, but somewhere in the course or somewhere in the book, there's this equation which is colloquially known as the parking lot equation. T wait, the time to wait is the time to shop divided by the number of spaces. And the students have memorized that equation, and all they need to do is put the numbers in the equation. And now all of a sudden we've dropped all the way to the bottom of Bloom's taxonomy. You're laughing about it, and maybe I exaggerate a little bit. I mean, I'm trying to be provocative here. But I would say a lot of our assessment tends to fall in that category rather than in the first category. And I think this is particularly important in the 21st century because computers can do this. And I predict that just as assembly line jobs have been replaced by robots, so will any job that requires the retrieval of factual information or the application of rote procedures be replaced by computers. So, therefore, we should really work on real problem solving, the type of problem solving that only humans can do, that cannot be done by a machine. But there's a problem with that because real problem solving is erratic. Right? You try approach 1, doesn't work. You try approach 2, it doesn't work. If you're lucky, approach 3 will work. The road to innovation, the road to creativity is littered with failures. Thomas Edison didn't just invent the light bulb. I think he had something like 300 failed prototypes. Most people would have told him, "You are crazy." But he persisted. He was not afraid of failure. Our assessment is incompatible with failure because it punishes students for making mistakes. You make a mistake, you lose points. Well, if you lose points, you're going to be afraid of losing points because you're going to be evaluated on those points. So, in a sense, our assessment practices discourage the students from taking risk, discourage the students from failure, and as I said before, no failure, no success. I'm shifting gears here for a moment. This picture that's on the screen here needs no explanation. You saw right away what this was. And if this picture evokes pleasant memories, I would like to talk to you after my presentation here. Look at this picture. What are some of the thoughts that come to mind when you see that? Go ahead, just blurt it out.
Pressure.
Pressure. Torture. Stress. These words are so conducive to learning, aren't they? Have you ever seen a 4-year-old or a 3-year-old learning things and, looking tortured? No, it's fun. There's something else, though, that is really peculiar about that picture. Or, not this particular picture, but the general idea there. Look at it. What is it that sort of, besides all these stress, torture, pressure, what else stands out?
Individual, one by one.
Individual. Isolation. Look at these people. They're cut off from each other, and they're cut off from any source of information. There's just pencils and erasers on there. Not even a calculator. I heard that in the US now, for SATs, and they have to take off their watches. Could be a smartwatch. So soon they'll have to be examined naked because you're laughing. I don't think it's funny at all.
Talk about stress.
Yeah. Since taking your last exam in college or in graduate school, can you remember any situation in your life where you've similarly been cut off from any information or any other person? I can't, frankly. When I do my work, if I write a paper about nanophotonics, there's not somebody standing next to me saying, you're not allowed to look up the paper by your colleague at Yale. You should have known this by heart. I can look up whatever I want, whenever I want it. I can talk to whoever I want. Real life does not involve this cutting off from each other from information. How can we imagine, think of it, that testing students under these circumstances will actually tell us how they're going to be able to operate later in their careers? They're not. Typically, assessment has been a high-stakes affair, culminating in the final exam. But as we know, high stakes, and instructors typically say to students, study for the exam. They're encouraged to study for the exam. But high stakes examination promote cramming, and as I already said, cramming stores information in short-term memory, and therefore there's neither any retention nor any transfer. Something interesting happened on my own campus. This was December 2013. I was in Hong Kong. And all of a sudden, I got on my phone an alert from the campus alert system. Bomb scare. It was around 9 o'clock in Hong Kong. I think it was 7:30 on the Harvard campus in the morning. Alert, if you're on campus, do not leave any building. There's been a bomb scare. I thought, what can that be? I turned TV on, CNN. There I see a picture of the Harvard campus, fire trucks, police, ambulances, yellow tape. It was the first day of examinations. And there was one student who didn't want to take the exam, so he called in 4 bombs in 4 different buildings. The exams were going to start at 9 o'clock. At 8:30 Cambridge time, I got a second message saying, all clear. It was just no bombs were found. 15 minutes later, I get an email from the dean addressed to the entire academic staff and students explaining about the bomb scare and that he reluctantly had decided to postpone the exams in those 4 buildings, even though everything was clear. Because of all the commotion, he had decided to take the exams that were going to be held in that morning in those 4 buildings and postponed them for 3 days. And he realized that was a problem for the students because they had studied for the exam. Hello? What? Study for the exam, postponing the exam 3 days is a problem? I mean, let's face it. Do you study just to pass the test? As this woman in the plane told me, and then you can conveniently forget everything? I think it was Einstein who once said, education is what is left after all that is learned is forgotten. So I find it actually a very sad statement, but there's so much truth to it. Okay. The other thing is that assessment produces a conflict. I realized that when I started teaching a project-based course, last 3 years I've taught a project-based course, rather than telling my students, here's my book, learn it, it's good for you. I tell my students, we're going to work on some really exciting projects. I try to include a component of empathy or social good in the project so that they really dig into the project. And then once they are hooked on the project, I tell them, by the way, you may want to have a look at this book because, it might help you with your project. So rather than focus them on the teaching, on the learning, I focus them on applying that learning. And then, of course, the learning will come along. So during most of the year, we have fairs every month. For the projects take 1 month. There are these project fairs. The first year that I taught that course, I was the judge at the project fair. And I realized that it was really hard to judge them. I mean, during the months, I'd been there with them, coaching them to be the best they could be. And now all of a sudden, at the fair, I became the judge. I wanted to give them A+, all of them. I knew how hard they'd worked. Can you imagine any other human endeavor where we mix the role of coach and judge? I mean, it would be unacceptable. These have to be different people. Right? You can't be the coach of a figure skater, let's say, and then go to the Olympics and say, bye, do your best, I'm going to be judging you. It would not be acceptable. How do we get away with this in education, with this conflict? The only way that we can get away with this in education is by applying objectivity, keeping out the emotions. We are going to assess you in a completely objective and fair and reproducible way. But think again about Bloom's taxonomy. The only skill that we can really assess completely objectively is all the way at the bottom. So in a sense, this conflict between coach and judge forces us down Bloom's taxonomy. Right? Creativity, I mean, people don't agree with what is creative or not. It will be impossible to have a really objective, reproducible assessment of that. So in a sense, this coach-judge conflict forces us down Bloom's taxonomy. And then there's grade inflation and cheating. Why would a learner be cheating? Have you ever seen a 3-year-old cheat while learning to tie shoelaces or put a fork in his or her mouth? No, of course not. Of course not. Cheating is not a problem with the learner. Cheating is a problem with our assessment practices. Anyway, I have about 10 minutes left. I don't want to end with a negative note. So let's talk about some improvements. The first one is let's mimic real life. Let's give students access to information. In fact, I knew that right when I started. I said, you know, I'm going to teach these doctors. Why would I force them to memorize all of these equations? I'm going to make a sheet where I put all the important equations on. So I gave the students that sheet during the exam. The next year that I taught, some students saw the sheet and they said, Professor, couldn't we not bring out our own sheet? This way, you know, I would rather like to organize the information the way I want it. So I said, okay, one index card, 5 by 3.5 inches, one side only to discover that they develop a microscopic handwriting in which they copy the entire book onto one sheet of paper. So the next year I said, you know what, you can bring the book to the exam. The following year, some students came to me and they said, Professor Mazur, in high school I used this other book in class which I actually like more than the book that you used. Could I bring the book that I used in high school? You know what, you can bring any book you want, okay? So because not all the students had used the same book in high school. So I said, you can bring any book you want. Some students would come in with 5 textbooks. The following year, some students came to me and they said, could I bring the solutions to the homework and my notes? I thought about it for a moment. And then I said, you know what? You can bring anything you want except another living person. But then more recently, I started to assess my students with their laptops, which means that they have access to Google. Is that a problem? I thought about it for a moment. And then I realized, no, it's not a problem at all. It's a blessing. Because any question to which the answer can be Googled is not an authentic assessment question. In fact, by giving them access to Google, I chop away that bottom level of Bloom's taxonomy. It forces me higher up. Rather than being forced down, I'm forced up. Of course, I have to check to make sure that my questions cannot be Googled, and that takes a little bit of time. But as a result, I know that I assess my students with much more meaningful questions. I'm going to jump again. I want to show you a little video which was taken in Indonesia, on the island of Java, in Bandung, at the Bandung Institute of Technology, which is Indonesia's top university. Students are talking in Malay, so you won't be able to understand it. I want you to look at that video and then decide, A, what is the discipline? And B, what are the students doing? maybe my first question was not very fair, right? I mean, what discipline is it? You can. I'll tell you. Statistics. Have you ever seen students have fun with statistics? Now you have. But secondly, what is it that they're doing there?
Cooperative learning.
Cooperative learning. What else? I think I heard it there. Somebody. Exam. They are taking an exam. Now, isn't that a cognitive dissonance, right? How can they be taking an exam and be having fun? The first time that I came across this comes from Teambased Learning, teambasedlearning.org. That website is actually very interesting to study. Team-based learning has an interesting approach to examination called the readiness assurance. And basically the first time that I came across it was at the University of Delaware in a biochemistry class. By the way, team-based learning is mostly used in management and in medical education. You can see how these teaching innovations are siloed and don't spread easily among disciplines. Only, after 15 years, it's finally starting to spread to the sciences. And the first time I came across it was a few years ago when I was Phi Beta Kappa visiting scholar at the University of Delaware, which means you're spending a few days on campus, you're visiting some classes, giving talks in different departments. And on my schedule was this visit to a biochemistry class. So at the appointed hour, I go to the right building, look up the classroom. I come to the classroom, 4 round tables with chairs, no students yet, and a professor who is walking around putting pieces of paper on the tables. I go to the professor, I introduce myself. He said, "Oh, it's great that you're visiting today. We have an exam." I said, I thought, that's weird. Why would... So I thought, this is great. I'll go outside and I'll do my email, right? I was behind on my email anyway. So I said, no. Don't go outside. I want you to take the exam. I said, what is the exam about? He said, hemoglobin. I said, I don't know anything about hemoglobin. But before I could protest, I found myself at a table with 7 other students. Anyway, we could start, turn the piece of paper out, and there were multiple choice questions. My mood went from bad to worse, because I don't like multiple choice questions. I don't know about you. So, because it's really hard to design good multiple choice questions. Anyway, with my limited knowledge of biochemistry and hemoglobin, I couldn't answer a single question, not even by elimination. I noticed that all of the students had a little piece of paper on which they wrote the answers, 1C, 2B, 3. So they wrote that on that little strip. I was just sitting there. After 20 minutes, the instructor collected those individual strips of paper. That's 50% of the grade. And then he put on the table, on each table, one of these if-at scratch card, instant feedback assessment technique. On the horizontal, A, B, C, D for the choices. On the vertical, 1, 2, 3, 4, 5, 6, 7, 8, 9 corresponding to the questions. 1 card per table. At the intersection, there's this paint that you have to scratch off as on a lottery card. And the card is pre-printed to have stars there where the correct answer is. So the first thing that the students at my table did is they appointed a scratcher. Do you want to be the scratcher? We found a scratcher. Right? That person was responsible for the scratching. And then the scratcher said, question 1 was really easy. I had C. What did you have? C, C, C. Everybody had C. So we scratched C. They scratched C, there's a star. They went, yes! I thought, okay, so now we turn it into a game. My mood was still bad. I was not going to buy into this. I wanted to do my email. But then we got to question number 2. And there, the students did not agree. Some had A, others had B. The A's didn't want the B to be scratched off. The B's didn't want the A to be scratched off. And something interesting happened. All of a sudden, it was no longer about the answer. The students went, don't you remember in class, the professor said that when hemoglobin, blah, 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 they started to talk like biochemists. And then at some point, they said, okay, probably it's B. Yeah, let's go. Shall we go with B? B? Okay. They scratch no star. Here's the genius of the method. If you get it wrong the first time, you can try again for half credit. So notice that they uncovered another square here. They got 2 points. On this question, where it was only at the third try that they got only 1 point. This one, they didn't get right in 3 tries. They got 0 points. So they went there, and there were actually students in the class who went, oh, yes. They were learning during the assessment. The assessment became a learning opportunity. By the time the hour was over, the students walked away relaxed. No stress, no pressure. And they had learned. Not only had they learned, they knew exactly what their grades were, because now you see what the answer key is, so you can check your own answer. You can check the team answer. You just add them up. 50% is the individual part, 50% is the team part. One condition for making this work is that you make the individual part hard enough that there is not a single student who gets everything correct. So typically during the individual round, the average is around 40%. And then during the team round, it's probably more like 80%. Right? Because if you have students who ace the individual round, then there's no learning taking place, because people know, oh, he's the smartest person in the class. When he says A, it's A. And they take things by authority rather than by learning. So you have to make sure that even for the best students, there's significant improvement possible. So the good thing is students walked out there having learned, they had their grade, immediate feedback. What's even better, no grading for the professor. It's all done. I thought that I loved it, but I didn't apply it to my own class because I don't like multiple choice questions. Why don't I like multiple choice questions? Because I suffer from the curse of knowledge. It's easy to come up with the right answer, but it's hard to come up with plausible wrong answers because my mind doesn't work like that of a beginning learner. The only way to design a good multiple choice question is to give it as a free response question, tabulate all of the answers, and then choose the most frequent mistakes. But I don't have time to do that. So that's why I actually developed learning catalytics. And once we had developed learning catalytics, we started to use that to assess our students. So now students can type in anything, an equation, or it could be a drawing, it could be words, and the system grades it. This would not be a good exam question because you can Google it. But for example, you can ask questions like this. What is the derivative of this function? And then students type in the answer as an equation, and the system parses the mathematics. Now, the students will do 10 or 12 questions like that. Then I press a button, and it puts it in the team round, and they see the same 12 questions. But now at the top of the screen, they can see what their teammates have. Ryan Lukoff, who took this exam, it's 6x minus 6. His team members, Brent, Beth, and Kip, had these answers. And they'll go, Brent, why do you have 6x? And so on. They go to the board. They teach each other. And then basically they reach agreement. They type in what they think the right answer is, and there's instant feedback. If it's right, they get 4 points. If it's wrong, they can try a second time for 2 points. If it's wrong again, they can try a third time for 1 point. If it's wrong again, they get 0 points, but the system will show the solution. Let me show you a little movie of how this works in practice. During the individual round, it looks like an ordinary exam, except that they have their computer in front of them, which means they can Google things. The only thing they're not allowed to use is email or chat or text message. That's the only thing I don't want. But then during the team round, it changes completely. They talk to each other. We were teaching the right-hand rule here. They'll go to the board. Do they look stressed? They'll go, aha. You know, I didn't capture that on tape. They'll go, yes.
How many students are taking the exam?
70 here. 70, yes. But it's been done with 300. I actually sometimes ask some of my colleagues to come and visit my class during the team round. I make sure that they don't come before the team round starts. So they walk into my class, they see this chaos, and I say, what do you think my students are doing? Just like I asked you a moment ago. And they say, well, group work, worksheets. I say, no, they're taking an exam. What? It's a complete cognitive dissonance. Yes?
How do you prevent them from using the email to send?
So we walk around, which is very easy in that room, and we tell them, if we see chat, email, or text message, you get thrown out of the course. I have one of the evaluation components for the course is ethics. And you have one incident of cheating, and you lose your ethics grade completely, which pulls you all the way down to a C at maximum. So the penalty is huge. Okay, it's huge. But also there's very little reason, right? I mean, the fact that you get the second chance together is actually a pretty big disincentive for cheating, right? Why cheat? I mean, you're going to find out the answer together. The most important part is really to get the team. You have an interest in doing as well as possible individually, but they know it's hard. They know that the average is only 40%, so they're not too worried about mistakes. Then the next thing is really to try to get your team to work as well as possible. So the important thing is it teaches you collaborative skills too. You have to figure out how to work with other students, which I think, look around you, look at companies, look at your own department, look at the people you work with. It's probably one of the most important skills we can develop. Second thing, let's focus on feedback, not on ranking. Well, go ahead.
How do you ensure that they're actually doing individual jobs in the first phase?
Well, because we're there, they can't talk to each other, and as I said, if we see email, text, or chat on their screen, they're immediately disqualified.
Also like verbal chatting, like.
Oh yeah, no talking, no talking.
Do you
Yeah.
choose the groups or they choose?
We make the groups. We make the groups. Yeah.
What about time pressure? Because usually in exams, the thing that creates the stress is the time.
Yes, very good. So the individual part has a time pressure, but the team part, we let it go on. If they want more time, they get more time. Yeah. Okay, so second, let's focus on feedback, not on ranking. We're so ingrained on this ranking, right? This student is better than that student is better than that student is better than that student, da-da-da-da, and so on. I think objective ranking is a myth. I can think of many people, like the one behind me, who were immensely successful, but dropped out of college. I'm on the admissions committee at Harvard for the graduate school. We get lots of applications. I see these transcripts, people who are just amazing, amazing. Straight A's, done this, done that. We got to admit this person. Then we admit the person, comes to campus, and we think, what? Can't even tie his or her shoelaces, so to speak. Is missing. Again, you find that there's a huge discrepancy between the grade record and the actual capability of the person. Let's look at some data out of my own class. This was before I changed my approach. Here you see the final grade for the course on a scale of 100. Here, on a scale of 29, is the result from this force concept inventory. So this measures students' performance or understanding of the concept of force using just word-based questions like the truck and the car questions. Okay? This is everything in the course. This was before I changed my approach. There is some correlation between the two, but it's not a very big correlation. According to the author of the test, anybody who scores below 21 does not understand the concept of force. Discussed in week 1. Momentum depends on force. Work and energy depend on force. Everything, torque, you name it, everything depends on force. If you don't understand force, you cannot really understand anything. Notice that there are some students who scored exceptionally high. Others failed the course, obviously, but some scored exceptionally high. There's a broad distribution. If you take professors and postdocs and graduate students, and you have them take that force concept inventory, the horizontal test there, they typically make 1 or 2 mistakes at most. So their scores will be in these last 3 bins. Everything correct, 1 mistake, 2 mistakes. Notice that there are some students in my class who get there, but there's still a huge spread of final grades. Look at these 2 students. This student was still an Aristotelian thinker, did not understand force, but got an A for this class. This student scored on that limited amount of material at the level of a postdoc faculty member, but got a C. Is this objectivity, or is it an injustice? Especially given the fact that there's been research that shows that if you take away the grade, you don't take away the assessment, you take away the grade. You still have students take an assessment, but then instead of putting a numerical grade, you put, this is great, this is wrong, you should have done this. You give feedback. The students actually take the learning so much more seriously because they don't have to worry about the grade anymore. It's all about the learning. But if you put the grade on there, they'll focus on the grade because that is what matters. In fact, they focus on it so much that they'll even cheat sometimes rather than going and learning. Third thing is focus on the skills, not on the content. Right? In a traditional approach to teaching, what happens is you make a syllabus saying, in this course we're going to cover topic A, topic B, topic C, topic D, and so on. Then you start teaching, and then you ask yourself, what am I going to assess? And then you design the assessment. In that case, the course is completely determined by the content. The way we should approach our curricular design is really to start at the output end. What do we want our students to be able to do after taking this course? That actually makes a lot of sense to most of my colleagues, and probably to you too. But actually, doing it is not that easy. I find a lot of my colleagues will think, okay, I'm going to write in my syllabus to my students, after taking this course, you will be able to, and then they think about it, understand topic A, topic B, topic C, topic D. But then, of course, you're back to where you started. So what you want is you want to have actionable verbs. After taking this course, you will be able to solve partial differential equations or this or that kind, or be able to apply Newton's laws of motion to blah, 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 and so on. Specific things. In fact, you have to ask yourself, what am I going to accept as evidence that I've accomplished those goals? And if you cannot think of evidence, then you have to reformulate your goal. And then last, you think about what am I going to put in the course in order to maximize my output. I think it makes a lot of sense. This is the way you would treat an engineering problem, right? The great thing is that in this case, the course is defined by the outcomes, not by the input. But what is more, you have thought about the assessment during the design of your course, because it's built in right there. So the assessment becomes more clear. What are you going to look at the end? Last thing is, let's resolve this coach-judge conflict. Do you know what I did for my project-based course? It was very simple. I asked my colleagues to come and be the judges. So rather than me making a Jekyll and Hyde transition from good guy to bad guy, let them be the bad guys. You know, let them, and I take people from the engineering department, from the physics department, who my students respect, and who they can see as objective and outsiders, and I can still be the good guy. I can still be able there to defend. Well, but you know, he really said this and meant that. I remain on the side of students. I continue to be their coach. And of course, I'm going to be happy to return that favor to my colleagues. I don't want to make more work for them. So I'll be the external evaluator in their courses. And also we should use, and I wish I had more time and my time is up, use more peer and self-assessment. Why is that so important? Typically, as a student, you hand in your work, and then 2 weeks later, you get it back marked with a grade falling out of the blue sky. There might be some accounting of points that you can verify, but still, you have no idea where your work stands in relation to that of others because you've never seen the work of others. There's a technique called calibrated peer review, which permits students, after passing a calibration step, to assess the work of their peers and also after that of themselves. So they see first some calibration pieces, then they see the pieces of their peers, and then they have to evaluate, self-evaluate their own work. And because of the calibration pieces, they're guaranteed to have seen a really good piece and a really bad piece. And maybe among the work of their peers, there's also a really good and really bad piece. They may think, wow, I wish I had written this piece. Or they may think, God, I'm better than all of them. You can place your work in your own eyes in the context of that of others. And again, learn from the assessment rather than just seeing it as a measurement. Well, my time is up, and I want to end with a call to action. The call to action is very simple. We must rethink assessment. Because if we do not rethink our assessment, I think we'll continue to educate the followers of yesterday rather than the leaders of tomorrow. But perhaps what is even more important, if we do not rethink assessment, our assessment results will not really be an adequate indication of who will succeed later in the career and who will not. So thank you very much.